This project focus on the closest pair of points problem and the algorithm which we use to solve. So first of all the closest pair of points problem involves finding the 2 points in a set of points that are closest to each other in terms of equal distance. And now talking about the two algorithms, we use our brute force algorithm and the divide and conquer algorithm. So like we can see the function here, brute force algorithm, in which we examine every pair of points, which will then result in a quadratic time complexity of n square. Then we use divide and conquer algorithm to the divide and conquer algorithm, which sorts the points, and then use recursive approach, which helps in reducing the time complexity from n squared to n log n. So in this, what we have done, we have made a function for finding the closest pair recursively, and then closest pair recursive helper will help in the closest pair recursive function, in which we have used the divide and conquer algorithm, which means like we divide to left of by a string into middle in left part and right part, and then keep dividing in recursively. Then apart from it, this function generate points is used to create random points for the input, and like we didn't give a input from ourselves, we design input cells, then we have function to measure runtime of an algorithm, which will help depends in how much time it is taking for the time complexity. Then in this we compute the hidden constant c, and then we are plotting graphs for both the algorithms with their empirical real time and the predicted real times. So let's take into the main function. So in the question itself, be given we have to take n values, 10 values. So like in my project, when I am taking more values, the output is not coming and it is taking a lot more time. So I have to sort it down to the smallest value with the intervals of from 500 to 5000. So our input size is this, and m is the equal to 10 is the number of iterations we are doing in the values. So like this you can see we have make two tables for algorithm, one which is of brute force and algorithm 2 which is of divide and conquer. So we have to take in for 10 values iterations. With the 10 value iterations, 500 to 5000, which we have there, theoretical value, empirical RT ratio, and the predictor RT, and the same for algorithm 2. So these are the graphs which we can see as the n value is increasingly, the runtime is also increasing for algorithm 1 and algorithm 2. So as we algorithm 1 takes n square root time, and so graph which shows the value is changing rapidly. Exponentially graph in for algorithm 1, but algorithm 2 doesn't know because it is taking less time of n log, and that can be seen in other two graph also, and we are comparing both of them as we can see in algorithm 1. the empirical RT ratio is constant and the predicted RT is increasingly, and same goes for algorithm 2 is taking n log n. So this is my experiment all.